Example number 1, solve using the quadratic formula. The first thing that I'm going to do is I'm going to label all of the key terms. A is 6, B is 5, C is negative 4. Now I'm going to plug them in onto the quadratic formula, so I'll get x equal to negative b, in this case that's going to be 5, plus or minus the square root of b squared. Here we have 5 squared. We're going to subtract 4 multiplied by a multiplied by c. A is 6 and C is negative 4. We're going to divide here all of this by 2 multiplied by A, and a reminder that A is 6. Let's begin to simplify. So here I'll get x equal to negative 5 plus or minus the square root of 5 squared, or that's going to be 25, and then we're going to subtract 4 multiplied by 6 multiplied by negative 4. Here the negative and the negative are going to change this to plus. 4 times 6 is 24, and then 24 multiplied by a 4 is going to give us a 96. On the denominator, 2 times 6 is 12. This is going to reduce to negative 5 plus or minus the square root of 25 plus 96 is 121. We're going to divide that by 12. Now 121 is a perfect square. The square root here is going to be 11. So we have negative 5 plus or minus 11 over 12. The two solutions are going to be x equal negative 5 plus 11 over 12 and negative 5 minus 11 over 12. Here on the left, negative 5 plus 11, that's going to be 6. And 6 over 12 reduces to 1/2. On the right, negative 5 minus 11 is negative 16. And 16 and 12, they have a greatest common factor of 4, or that's the biggest divisor, so this is going to reduce to negative 4 over 3. Moving on to example number 2. Here we have to solve using the quadratic formula as well. So the first thing is that I'll label all of the key terms of the trinomial. A is going to be negative 1, B is 6, and C is negative 9. Now I can plug them in onto the quadratic formula. So here I'll get x equal to negative b, and b is 6, plus or minus the square root of b squared. So here we'll get 6 squared, and we're going to subtract 4 multiplied by a and multiplied by c. We will divide this by 2 multiplied by a. A and c, that's going to be negative 1 and negative 9. And a reminder that the a value is negative 1. This is going to simplify to negative 6 plus or minus the square root of 6 squared, which is 36. Here we have negative times negative, which will change to positive, but then we'll multiply another negative, so we'll have a minus here. Now we can multiply the terms, or the numbers. 4 times 1 is 4, and then 4 times 9 is 36. And on the denominator, 2 times negative 1 is going to be negative 2. Now here underneath the radical, 36 minus 36, we're going to get 0. And the square root of 0 is going to be 0. Here on the right, this is going to cancel out. So we in reality just have negative 6 over negative 2. And a negative divided by a negative is positive, so the solution here is going to be 3, positive 3. Whenever you get 0 underneath the radical, that means that this solution occurred twice. It's a repeated solution. Let's move on to example number 3, solve using the quadratic formula. Now notice that for this example, we don't have a trinomial just yet, but we can fix that if we add 2x to both sides of the equation. On the left hand side, we're going to get 0. And on the right hand side, I'm going to want to write this in standard form, meaning that the highest power is going to get recorded first. So I'll write x squared first, followed by 2x, and then the constant is going to remain at the end. Now that I have the quadratic in standard form, I can label the a value, the b value, and the c value. I'm going to plug them in onto the quadratic formula, so I'm going to get x equal to negative b. B is going to be 2, plus or minus the square root of b squared. So here I'll have 2 squared, and we're going to subtract 4 multiplied by a multiplied by c. A is 1, and c is 5. We will divide all of this by 2 multiplied by a, and reminder that a is 1. This will simplify to negative 2 plus or minus the square root of 2 squared, which is 4. We're going to subtract 4 multiplied by 1, which is 4, and then 4 times 5, that's going to be 20. On the denominator, 2 multiplied by 1 is going to be 2. This is going to equal negative 2 plus or minus the square root of negative 16 all over 2. Now we have a negative number underneath the radical, so when I take the square root, we're going to have the imaginary unit. The square root of 16 is 4, so we're going to get negative 2 plus or minus 4i all over 2. Now 2 and 4, they share a greatest common factor of 2, so I'll factor that out, leaving me with an x equal to 2 multiplied by negative 1 plus or minus 2i all over 2. And here the 2's are going to cancel out, so my solutions are going to be x equal to negative 1 plus 2i, and x equal to negative 1 minus 2i. Moving on to example number 4, we have to solve using the quadratic formula. We have a trinomial, so I'll label the a, the b, and the c, and next I'll plug them into the quadratic formula. Here I'll get x equal to negative b, and the b value is negative 3, plus or minus b squared, so we'll put negative 3 squared. We're going to subtract 4 multiplied by the a value and then multiply it by the c value. A is going to be 1 and c is going to be 5. We're going to divide all of this by 2 multiplied by a, and the reminder that the a value for this example is going to be 1. Simplifying this, we're going to get negative, negative, make positive, so we get a positive 3 plus or minus the square root of negative 3 squared, which is going to be 9. And then we're going to subtract 4 multiplied by 1, which is 4, and then 4 multiplied by 5, that's 20. And on the denominator, 2 times 1 is 2. This is going to simplify to 3 plus or minus the square root, and 9 minus 20 is going to be negative 11. We're going to divide that by 2. We won't be able to simplify the 11, but we can take out the negative 1 by exchanging it for an I. So here we'll get 3 plus or minus I root 11 over 2. So my two solutions are going to be x equal to 3 plus I root 11 over 2, and x equal to 3 minus I root 11 over 2. Moving on to example number 5, determine the number of real solutions for each of the quadratic functions. In order to determine the number of real solutions, we're going to need to calculate the discriminant, that is b squared minus 4ac. If the discriminant is bigger than 0, we're going to get 2 real solutions. If the discriminant is less than 0, we're going to get no real solution. And if the discriminant is equal to 0, we're going to get 1 real solution. Let's begin by calculating part A. Labeling all of my key terms, now I'm going to evaluate b squared minus 4ac. So b is equal to positive 3. So we get 3 squared. And then we're going to subtract 4 multiplied by a and then multiplied by c. So multiplied by negative 4 and multiplied by negative 5. 3 squared, that's the same thing as 9. And then here we have a negative times a negative, which is going to be positive. But then if we multiply by another negative, we're going to get negative right here. 4 times 4 is 16, and then 16 times 5, we're going to get 80. And 9 minus 80 will give us negative 71. So the discriminant is negative 71, and this is less than 0, so we're going to have no real solution. Moving on to part B, we're going to do the same thing. This time b is going to be negative 12, so we're going to calculate negative 12 squared. We're going to subtract 4 multiplied by a multiplied by c. A is 9, c is 4. Negative 12 to the second power, we're going to get 144. And then we're going to get minus 4 times 9 is 36, and then 36 times 4, we're going to get 144. And 144 minus 144 is going to be 0. So here we're going to get 1 real solution. Moving on to part C, we're going to do the same thing, identify A, B, and C, and then calculate the discriminant. So b squared, here we're going to have 4 raised to the second power. And we're going to subtract 4 multiplied by a multiplied by c. The a value is going to be negative 1, and my c value is going to be negative 4. So we're going to get negative 1 multiplied by negative 4. 4 raised to the second power is 16. And then here we have a negative times a negative, which is going to be positive. But then if we multiply by another negative, this is still going to be negative. 4 times 1 is 4, and then 4 times 4 is going to give me 16. And 16 minus 16 gives me 0. So we're going to get 1 real solution here. Finally, for part D, again, let's label the A, B, and C and begin to calculate the discriminant. So here, my B value is negative 3. So I get negative 3 raised to the second power. We're going to subtract 4 multiplied by A multiplied by C. A is 14, C is negative 2. And negative 3 squared gives me positive 9. We're going to subtract, well actually, we have a negative times a negative, so we're going to get positive right here. And then I'm going to do 4 times 2, which is 8. And then 8 times 14 is going to give me 112. And 9 plus 112 is going to give me 121. The discriminant here is positive, and this is bigger than 0. So here we're going to get 2 real solutions. Let's move on to example number 6. Match the solution type with the graph features. Now here, if we have 1 real solution, then that means that the vertex is going to be the x-intercept. When we have 2 real solutions, the graph crosses the x-axis twice. And for 0 real solutions, the graph does not cross the x-axis. And here are some examples on what your graphs could potentially look like. Example number 7, identify the key features and then graph the function. So I'll begin by calculating these three first. So let's begin by identifying the a value, the b value, and the c value. The concavity, if the a value is positive, we're going to get concave up. If the a value is negative, we get concave down. Since we have a positive 1, we're going to say that this is concave up. The y-intercept for a quadratic that's in standard form is the coordinate 0, c. And here, the c value is 4. So the y-intercept is going to be 0, 4. To get the x-intercepts, I'm going to make use of the quadratic formula. So here we're going to plug the values in. So negative b, that's going to be negative 6. Plus or minus the square root of b squared, so negative 6 squared. We're going to subtract 4 multiplied by a multiplied by c. The a value is positive 1 and the c value is positive 4. And then we're going to divide all of this by 2 multiplied by a. And a is positive 1. This is going to simplify into negative make positive, so we get a positive 6 plus or minus the square root of negative 6 squared, which will simplify to 36. And then we're going to subtract 4 times 1 is 4, and then if we multiply 4, we get 16. For the denominator, 2 times 1 is 2. So we get 6 plus or minus the square root. 36 minus 16 gives us 20. Now the 20, I can get its prime factorization. That's going to be 5 times 4. And then the 4 is 2 times 2. Since I have a pair of 2's, remember that here we want to cross out the pairs, and for every pair that we cross out, one of that quantity is going to be outside of the radical. So here this is going to be 6 plus or minus 2. And since the 5 I couldn't pair it up, that's going to remain underneath the radical. On the numerator, 6 and 2, they share a greatest common factor of 2, so I'm going to factor that out. Giving me a 2 multiplied by a 3 plus or minus 1 radical 5. Now I can simplify the fraction, the 2 over 2. That's going to cancel out to 1 over 1. And my exact solution is going to be x equal to 3 plus or minus radical 5. Writing them separately, I get 3 plus radical 5 and 3 minus radical 5. And I should point out that something that I noticed here is that when I posted the formula, I forgot to put a plus right here. So this is plus or minus, okay? Now that I've recorded the exact solutions, I need to get the approximations. And with the help of a calculator, I got 5.24 for the first one and 0.76 for the second one. Now let's calculate the axis of symmetry. And to do that, we have to calculate negative b all over 2a. So here we're going to get negative b, and b is negative 6. We're going to divide that by 2 multiplied by a, and a is 1. On the numerator, negative 6 is going to become positive 6, and then on the denominator, 2 times 1 is 2, and 6 over 2 is 3. That would be the axis of symmetry. To find the vertex, we're going to plug in the axis of symmetry onto the equation. So we're going to get y equal to 3 squared minus 6 times 3 plus 4. 3 squared is 9. 6 times 3 is going to be 18. And then we have a plus 4. Next, 9 minus 18 is negative 9. And if we add 4, we're going to end up with negative 5. Y equals negative 5 when x is equal to 3 together the vertex is 3, -5. The only thing left to do now is to graph the function. So I've translated all of the key values that are going to help me do a nice sketch of the parabola. So beginning with the y-intercept, that's going to be at 0, 4. Next, I'll plot the vertex 3, -5. So that's going to be at 1, 2, 3, and then we're going to go down 5. 1, 2, 3, 4, 5. Next, we are going to plot the x-intercept, so 5.24.76. We're going to have to use our best judgment here and approximate that on the x-axis. So beginning with 0.76, that's going to be somewhere here. And 5.24, maybe somewhere around here. Now, I'm also going to create the axis of symmetry by cutting or running through the vertex here. And I'm doing this because I want to reflect the y-intercept. So this is 3 units away from the axis of symmetry, so the reflection also has to be 3 units away. And we have a sketch of the parabola.